Okay, does it show live on your end?
Yeah.
Okay, and I'm sorry for the really bright light behind me.
Oh, that's fine. I can see you.
Okay, good. That's what matters, I guess, right?
Right.
Okay.
So should we just go over the prep assignment first?
Is that what you guys did last week? I mean, earlier this week?
No, we jumped in. So I guess maybe we could jump in. I think I've got an okay idea.
No, you're fine. Did you watch the video by chance?
I watched her video and I watched the
The
video
two?
that the guy made.
The two videos? I don't
Yeah.
know. That's what I watched, and I was like, okay, this doesn't look too bad, but maybe I'm mistaking myself.
I think we just need to get like the concept down, like and like what the equations are trying to where they're trying to get us. And
For
I
what
think
they're asking for.
yeah, and I think then we'll be okay.
That would be good. Okay.
So yeah, we can start with
All
we
right.
can just do the quiz, and if we don't do very good, maybe we can go back through.
Yeah, that's totally fine with me. I mean, thank goodness we get 2 shots, right?
Right, yeah, seriously.
Okay. So let me know when you've got it open. Oh, no, question 3 is fairly easy, thank goodness, I think.
All right. Is no colored building.
So it looks like they're just asking for the right and the left of the applet. Is that correct?
This is the combined area.
Yeah, under the standard normal curve that is to the right of the one z-score and to the left of the other z-score.
Yeah, I think you're right.
Okay, awesome. So I got 0.1745, which I guess would round up to 0.175, but let me know if you get the same answer.
All right, just a second.
You're good.
Yeah, 0.1745.
Yep. So we'd round it to 0.175, right?
Yeah.
Because it's 3. Awesome. Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from the population? Okay.
This, yeah.
All right, let's see. Okay, so smaller standard deviation. So we are searching for the standard deviation if 9 observations are randomly drawn. The distribution of the individual observations.
I think.
Go ahead, sorry.
I think either that one
Or the second one.
or neither of them. Because.
Okay.
No,
No, you're fine. I don't know the answer, so I'm looking at the.
I mean, because in your individual observations, you only have 9 samples.
Yep. A smaller.
For the distribution of sample means, you have pretty much everything, right? I guess we could. You can't do the math.
Let me see.
We don't have anything to do the math on.
Probabilities involving a mean. Finding the area under a normal curve.
Distribution of individual observations. So I guess I'm having a hard time determining the difference between just X and X bar.
Yeah. That's what I'm trying to look for.
What is the difference? Do you know?
X bar is like your sampling mean, okay? That's what we said, sampling mean. Times X is just when you've done the population. It's like the difference between a population and a sample. X is like your population version of that equation. X bar is your sample.
Okay.
Seems like X, this is not your, is that just a mean?
No, it's a value. It's right now it's a random variable.
Okay.
Go
So
ahead.
this is saying something, it says under, for in the reading, it says review of key concepts. It says, once you have determined the sample mean is normally distributed, we can compute probabilities with the X with the bar over it. Does that mean anything?
Once we've determined that the sample mean is normally distributed, we can compute probabilities with X bar.
Okay.
We first compute the z-score and then use the normal probability output to compute probabilities about it. Oh, okay. So, like, we might get a question like they'll give us the mean, the standard deviation, and then the sample size, right? And then once we get that, then we figure out the z-score, put it into the applet, and then it'll ask us questions like number 3, like
Yes.
less than this number and more than this number, what is that combined? Does that make sense? I think that's what it's saying.
I think so.
I'm pretty sure. But
Okay, so does that mean we think it's A or B? Should we skip that one and we can come back to it?
yeah.
Okay.
And maybe we're just like overthinking it.
Yeah. Which of the following results implies that the spread in X decreases as the sample size increases?
Decreases as the sample size increases.
So the equation.
There is no equation. It's just asking us this.
Right, but it's your main equation. You
Oh.
can looking at your X bar. So if you pull up that equation, you can kind of look at it and figure out what is it? If X bar decreases, what increases? What was the question? Let's see. Spread of X bar decreases as the sample size increases.
Oh.
Okay, I'm just leaving somewhere else.
Yeah. The spread, so is that the standard deviation? Because this,
It's your
the
sample
spread.
mean.
Okay,
Oh, the spread.
the problem I'm
here.
having is that I'll share my screen.
What's your standard?
Okay.
So there's this X bar by the sigma, and then there's this X bar by the mean.
Right.
So which one is it talking about? It said spread, so I'm guessing it's talking about the standard deviation.
For your sample distribution.
Here's
Yeah. So you've got
Distribution.
population is on one side, and then there's one thing, and then there's samples. So
which
yeah,
of the following results applies
and the spread.
decreases.
So you're right. The spread of your mean is your standard deviation.
So if it's decreasing, standard deviation is decreasing, the sample size increases. It's not the central, well, it's not the law of large numbers, I know that.
I don't think it's the central limit either.
I don't think so. So it's either normal distribution or, oh, what if, it's probably the rule because,
The spread in X decreases as the sample size increases.
yeah, because, like,
Let me look at one more thing.
is there anything about that in your reading?
That's what I'm looking at.
Okay. And
Okay.
It could be that first one.
implies that the spread. Yeah, that could be it too.
Why is it the spread
You're
decreases?
if you were getting more spread with more samples, something funny could be going on. I just don't even know what that is.
I'm not sure myself.
What the sample is,
I'm not sure myself.
off the top.
Well, the 68 is the first deviation.
Okay.
95 is the second deviation, and 97 is the third deviation.
That's right. Yeah.
This is the sample size increases, the standard deviation of the mean decreases, and the sample size too. Standard deviation of the sample increases.
What's your central limit there?
That is the bigger your sample size, the more normal the shape will be. Let me look.
Okay.
when the number of samples increase. That makes the shape more normal.
Without the answer.
Comes closer to the population mean. No, because the sample size.
Your sample size is getting bigger and all your data's getting closer together.
I think so. The more it comes closer to the population mean, or 50%.
The larger your sample size gets, the closer you will get to it.
Right. All right, did you hear that?
No, sorry,
Okay.
I've been reading a ton of stuff to try and like see if I can get an answer. What did you say?
Oh, you're fine. I guess I can stop. So the central theorem and the role of large numbers,
Mm-hmm.
they say that the bigger your sample size gets, like the more normal the shape will be,
Mm-hmm.
and the closer it will be to 50%.
Okay.
So like the closer, the smaller the
Oh, the spread would be from one side to the other.
spread would decrease.
Yeah.
So I think it might be one of those two. I'm not sure. Yeah, exactly.
Do we want to guess the law of large numbers? I saw somewhere else that it seemed to like imply that it might be the law of large numbers, but I wasn't 100% sure.
Let's try that.
Okay.
I think so. Because the central limit theorem just says that the more normal it becomes,
Mm-hmm.
but it says the spread decreases. I don't know.
Your guess is as good as mine. Based on what I read, I think I agree with you for what you're saying, because that, based on what you said and what you're saying and what I read, that makes sense.
Okay. What did you read?
Well, I sometimes look at like courses and see if I can find sample questions that like read the same, but maybe like give the answers and explanations. So I read something similar that implied that like the large numbers would be the answer to that because of that piece of what you were talking about, if that makes any sense whatsoever, which it probably doesn't.
That's fine. Okay. All right. So let's go with that one. And now here's some math. So.
Yay. Okay, let me go get a piece of paper really quick. Do we have any paper?
All right. So x minus. What's the z-score?
Okay.
What is the z-score for? Okay. So this one's pretty easy because we've already been through the z-score just a few weeks ago.
So it's just solving for it?
Yeah.
Okay, so is it saying? So is it saying 160 minus 50.8? I mean 150.8 divided by 8.8?
Yeah, 160 minus 150 divided by 8. Yeah.
150.8, right?
Yeah. Divided by 8.8. I got 1.045.
And then it repeats like 454545.
Yeah.
Okay.
So would it be 4.6?
Yes. 1.0. No,
No.
it would be 1.045 because the next number after that's a 4, so we would keep it the way it is.
Okay.
Okay, so we're going to take that z-score and put it into the applet, correct?
No, I think it's just asking for the z-score. It's not asking for.
Oh, for the next answer, sorry.
Oh, it's okay.
For number 7.
Oh, yeah.
So it would be everything to the right of the z-score, right? Okay. So then it would be, I got 0.1480. What did you get?
Yep, 0.148.
Okay, awesome. Okay.
So that wasn't terrible.
No, that was bad. We're doing good.
But I shouldn't speak yet, right?
Okay. We're doing awesome.
Yeah.
We'll take what we can get, right?
Exactly. All right, so now we've got to calculate the mean and the standard deviation.
Huh?
Oh, I made a thing for this.
You made a thing?
Yeah.
That sounds exciting.
I made a z-score calculator.
Oh.
Yeah. I just need my keyboard.
Okay, so I'll grab you the mean.
Is our dishwasher like super loud? Can you hear it?
I don't think I can hear it.
Oh, good.
The background noise, but
Super
nothing
loud
crazy.
to me, so.
They're like, turn it off. Is it in like your kitchen or something?
It's in our kitchen, living room, dining room. We're kind of all combined.
Okay, cool. / laundry room.
Luckily not, but
Oh, good.
yeah.
Okay. All right, so I think 160 is the mean. Well, let me check my math.
That's what I got too.
Yep. So 160 is the mean, so that means in order to
Standard deviation is 10.049.
401.
Correspondence. What is the z-score? So if we go mean,
So, correct me if I'm wrong, Bailey, but are we using 10.041 as the standard deviation or 8.8 that was given to us before?
I think this is a whole nother problem.
Because it says use the following information for the next 4 questions.
Oh, all right, well.
I mean, I'd love to be wrong. I don't.
No, you're probably right. Oh, okay, so. So this is the population mean, it looks like. So they give us the population mean and the population standard deviation. So what we need to do is find the sample mean, which we already have at 160, and then find the z-score. That makes sense? Does that make sense? Boston.
Hello.
Okay.
Sorry about that.
That's all right.
It apparently stopped working for only me. I looked at my husband as I was doing that and I was like, what happened? Like, who broke it? Apparently. Okay, so did we decide that we would use the standard deviation we were given?
I'm not entirely sure. So I think that that is the population standard deviation. The sample standard deviation. Okay.
Let's see.
Oh.
Because it just says scores on the quantitative portion of the GRE are approximately normally distributed with the mean of this and a standard deviation of this. So if our mean changes, does that mean our standard deviation changes? Is that what you're saying?
So right here it just says, what is the z-score on question 8? What is the z-score corresponding to the sample mean of these student scores?
So maybe
So the sample mean
Because we're not using the same mean we had before, correct?
Right.
Okay. Then let's use your number.
Huh?
Then let's use your number. I'm fine with that.
So 160, but I don't know whether to use. I'm guessing we'll use the sample standard deviation. But I need to make another calculation to do that.
Does that,
Ty, I need help. Hi.
sample mean?
I
So
need
cause
help.
So the value, does that mean we need a new value? Because we have the mean, right? And you just gave us the standard deviation, is that right?
Well, we don't have the sample standard deviation yet.
Okay,
So I'm working on it
okay.
at the moment.
No, you're good.
Because the sample size is 5, so we need the square root of 5, or whatever it's called.
Okay, would you walk me through how you do this? Because I don't think I know how.
Oh yeah, sure. Let me
Thank you.
pull up. Okay. Barely got my bearings about it, so
You what?
trying to get my bearings here.
Oh, you're fine.
Okay, so if you look up here, it talks about the population mean. Okay,
Okay.
okay. So this is the population mean, and then this is the sample mean, and we got 160.
Mm-hmm.
Okay, so then we need to find the sample standard deviation. So for the standard deviation, I got 10. Mm. 0.049. Okay, and then divide that by how many samples there were, which was 5. Right?
5. Uh-huh.
Okay, and then so basically the equation looks like this. It's 160 minus the no, it's
Because it's minus 160, right? So it's x minus 160.
yeah, and then divided by whatever this number is. So just give me a second.
Oh, you're good.
That's 4.4.
Okay. I'm going to times this by 4.94.
So x divided by 4 equals
160, right?
35.6.
So would it be 160 times 4.494 then equals X?
No, I think so. So what I did here, this is basically what I'm doing. I'm just kind of separating them, right?
Okay.
Equals X. Six. But I don't think that's right.
So wouldn't it be
But
the,
we're trying to find the z-score, so X is 160. Wait, okay, sorry.
160 is the mean, right?
Yeah, you're right. I'm just trying to figure out,
No, you're fine.
because we're supposed to find the z-score, but we don't have X.
What is the z-score corresponding to the sample mean of these students? A random sample. Yeah, we don't have X because we don't have the value.
Mm-hmm.
And we also don't have Z.
Right, exactly. Yeah.
So
Hold
then,
on, let's see. X. I mean, there's got to be a way to find X. So maybe we're missing.
okay. Sample mean of the student scores. Okay, the distribution of the. Sorry, I'm trying to read in the reading too and see if I can find what I'm.
Yeah, you're fine.
Okay.
I mean, I've been through this before today, but it was asking for the shape of the curve and not the z-score. So that was fine.
Mm-hmm.
Oh, but how did I?
And the probability that the mean.
I'm gonna look through her video and see.
No, you're good. That's totally fine. I'm looking at the reading, so you're good.
Oh.
Is it easier than we're giving ourselves credit for?
I'm not sure. I think so. I think. So I think where we're getting caught up. Oh my gosh. Okay, I think I have it.
Okay, explain,
Okay.
please.
All right. Yeah, of course. Okay. Okay, so OX equals Can you see this?
Yes, the screen with the graph thing on the left, the sampling distributions on the left. Yes, I can see that.
Yeah, so the sigma x bar, so the standard deviation x bar, or the sampling standard deviation equals the population standard deviation divided by the square root of the number of samples. So all we need to do is divide
The mean?
all we need to do is take this population standard deviation, which is 8.8,
Okay.
divided by the square root of 5. And that will be our, that's going to be our sigma. That's going to be our sample standard deviation. Does that make sense?
Yes,
Okay.
kind of.
Okay.
So we have the standard deviation, right? But we don't have, how do we find x?
So we don't need to find like just it. Oh gosh.
But go back to what you were doing before, because it looked like, were those numbers the same in her video?
Yes, they were.
So,
Well, she was just checking her math. She was just checking. So this does the math for you. And she was just checking the math over here.
okay, is she doing the same exact problem?
Yeah, she's just writing it out for us.
So is the answer, okay. Okay, let's see. How does her video say to solve x?
It doesn't. There's nowhere.
You're fine.
No, it's fine. There's nowhere in the reading in the videos that it tells you how to solve x, because x is just a random variable.
So how does she say to find the z-score then, based on the information we have?
I don't think she does. I think it might be in that guy's video.
Okay, let me, hold on. I'm gonna open up the video and see if I can find an answer. So hold on.
Okay, thanks.
Yeah, of course.
I'm going to take a bathroom break.
No, you're good. I'm gonna look at this and you go right ahead.
Right, this your turn. Hi. Take that.
Right.
I just don't want to.
This is so frustrating.
What if,
Sorry, I'm watching the videos and it doesn't, even like where it says the like lesson 7 video tutorial,
mhm.
none of the questions match up with what we're doing.
Isn't that frustrating?
It's as frustrating as I'll get out. Like
Mhm.
none of them match up.
Yeah.
And they're like, oh, but the
Yeah, it's
content's similar. And I'm like, that can't be true.
funny.
You are lying. Okay.
So what I'm wondering is if we just use the sample mean that
Okay.
we found, which is 160, and then subtract that by the population mean.
Okay.
That's the only thing I can think of.
Well, it may be worth a shot. Well, and here's what we can do. I mean, we can maybe, what we could do is maybe email our teacher and say, hey, we're having issues with these questions.
Yeah.
Do you have a few minutes that you could go over them with us at some point?
Yeah. I think that'd be great because it's not due till tomorrow.
Yeah. Okay. So let's do that and see how well we do, and then we can go from there.
Yeah, and we can talk to Greg too and see how well he's feeling about it because he helped out a lot last time too.
Yeah. And this is frustrating.
It is.
Actually did the press shoot. Can you see me okay?
What's that?
Okay, you can see me. Okay, good. I thought I froze for a second.
No.
Okay, so question, where's her video? Because I could only find the video of the guy.
Oh, so it's on the announcements on iLearn.
Okay, that's
Yeah.
fair. Okay. So does she walk through this question?
No,
Okay.
she's just kind of explaining like what everything means. She doesn't even try to find a z-score, I don't think.
Oh,
Which is
look at
frustrating.
this. Law of large numbers is associated with the sample mean. As the sample size n gets larger, the sample size will get closer to the population means. I think we were right in that answer, by the way.
Okay, great.
Okay. So
I mean, we can input answers and then just hope for the best, I think. Till tomorrow, then we'll have to redo everything, which is fine, but.
yeah. Hey, I mean, we got to at least try and submit something today. And if we do well, then great. If not, it'd be nice to still have somebody walk us through it.
Yeah, definitely.
So, yes. Okay. So,
Divided by. So I got 1.045. What?
That can't be right.
No, that's the same answer as before. That's because that's the answer to number 6.
Oh, lovely.
Yeah.
Okay, hold on.
Or what we could do is use the population mean as that value x. Just kind of switch it around. Then we have to find that.
Okay, so this is gonna sound funny, but I was looking online for like an answer to see if I could find some help on this, and I found a sheet. It's from Course Hero that's supposed to help like kind of walk you through like the information and then like give you the answer.
Okay.
So, and it matches up with all of the answers that we've gotten thus far.
Okay.
And it gives an answer of 2.338 for number 9. I mean, for that question we just did.
For 8.
Yeah.
2.238.
Yeah. I mean,
I got, so for the square root of 5, I got 2.236.
so maybe that's it. All I'm saying is that where we have to kind of ask for help anyways.
Right. No, that's a great resource.
And not all the answers and things are listed here, but it's asking for the exact same thing.
Okay.
I don't know exactly if it's 100% correct, but I figured at this point it may be worth a shot.
No, perfect.
All right.
So does it walk you through?
It doesn't really walk you through it. It just kind of like, it gives you the answer based on the data that they have of like what the answer should be. And the thing is that I think it does explain why it is, but it's blurred unless I pay for access.
Oh, that's good statement.
I'm like, yeah.
That's a no. Okay.
Yeah, pretty much.
So I just don't want to use the answer.
And have it be wrong.
Or
Or
not that, just because we don't
we
know
don't know how we got there. Let's see. Let's see if it'll give me access.
What numbers did you put in? So like, this is my Excel sheet. Can you see it?
Yes.
Okay. Well, we've got 160, and then we've got the standard deviation. Except this standard deviation is 3.936. We still won't have X. So what I'm wondering is, did you have to put X in for your website thing? Or
Are you
like what
talking
numbers?
It
Yeah.
doesn't give them, like, I can't see the sample of what they have, how they did it.
Right, but like,
It gave me sorry, I'm not sure if I understand what you're asking.
so like, you said that you put in numbers and it'll calculate it for you. So like, where did you put the numbers? What numbers did you put in? Maybe
To get that answer.
Yeah.
So it only gave me the answer. It didn't give me the full, like the rest of it's blurred.
No, like,
Sorry, I'm not understanding, I guess, what you're asking.
that's okay. Stop sharing my screen. Do you mind pulling up your screen and showing me, like, so for the website that you're using, do you have to put in certain numbers in like certain places?
No, it just gives like the question and then it gives like the answer and then how they got to it is like blurred.
I'm sorry. Okay.
No, you're fine. I was like, I don't understand.
Okay. I was thinking like it was like in Excel where you just like put in numbers here and there. And I was like,
You know what I'm wondering is maybe if we work backwards with that number, if that would give us the answer to X. And see if that would make sense according to what we have been doing.
right.
We could try that.
Yeah, let me call the math expert over. Because the way I'm doing it, I don't think works. Okay? We need help. Can you hear me?
No, you're fine.
Okay. We need your help.
Oh, you did?
Yeah. Yes, I've been talking to you.
Okay.
Okay, so if I work that backwards, it gets me 183.476.
183.
0.476.
Okay. I think that's pretty high.
That's what I thought too.
I think I just deleted all my math.
Oh no.
Shoot. So, okay.
We're just calculating using.
Yes, but the problem is we don't have X. But we can't solve for X unless we have Z, the Z-score, right?
Right.
So we
But
just,
you do have your X bar.
how do we find,
Your sample mean. So add all those up and find your mean.
it's 160, that's my sample mean. corresponding to the sample mean. But we still don't have x. Or is this x?
Well, that is x, right? Well, it's not the same. You've got your other, don't you have like two equations? One of them's like x bar minus.
One of them is the mean x bar and one is the standard deviation x bar.
Mhm.
So if this is x,
Mhm.
do we need to find the standard deviation x bar to get the z-score?
Gotcha.
Still there?
Yeah, I'm here. You're good. I'm just reading. You're fine.
Yep, you should be able to figure out your standard deviation from that. Your sample standard deviation. Okay, like an equation for that.
We've already done that, and that is 1.045 that we've seen earlier.
Okay.
So we take the mean of the population and put it here.
We use the population standard. Y. Okay, keep going, I guess.
So x is the value.
Minus your standard deviation.
No, minus your mean.
Okay. That's right.
Divided by the standard deviation.
Okay.
Divided by
Screwed your number of samples.
standard deviation is 8.8.
There you go. Looks like you got it to me.
Except the
What?
I say we should just go for something and be done.
Okay, do we want to just skip
I
it?
think you did that right.
Well, I think I have a possible answer, but I don't know if it's right, so.
Okay. Okay. Sorry, I'm sure you're just as frustrated as I am sitting here going, this sucks. I hate this. It's fine.
So I got,
Looks like you did it right.
okay, I got 2.337.
Okay. How did you get to that? Just so
Yeah.
I was trying to listen and I was like, I'm not sure if I understand what.
No, you're fine. I'll show you. Should have just had it up the whole time. So X bar, so
Okay.
this is the sample mean, right?
Uh-huh. Is
what we
160.
calculated. Yeah. This is the population mean.
Yep.
This is the population standard deviation.
Uh-huh.
This is the sample standard deviation. Does that make sense?
Yes. Hold on. I'm just getting 3 point, and is that 3.936?
Yeah.
Okay. That makes sense. If it's that easy, I think I might. I can't believe that. That would be kind of funny if that was the correct answer, which I'm
Well,
sure it may be because it's easier than.
yeah, I think. Well, I'm just having a hard time figuring out where
X.
to put what.
Yeah, no, for sure. That's what I don't understand either. I'm like, I don't feel like we obviously don't have Z to work
Right.
backwards, which means we also don't have X based on what we have.
It's just the sample mean has got to be X. I mean, there's no other explanation.
Yeah.
So.
Yep.
mm.
So where did mine go? So the next one we get to use the applet. Yay. I think. Okay. As I closed it. Normal go me.
Over the 5 rounds have a mean score that is greater than mean achieved. Score.
So don't we just put it into the applet and it's just everything to the right?
Yeah, so 2.337.
Mm-hmm. So 0.0097.
Mm-hmm.
Oh, so it would just be 0.00. No, 0.01. Right?
Round your answer to 4 decimal places, so we can put
Okay.
97.
Okay, awesome. All right. Suppose the mean GPA of a BYU Idaho student is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable, which represents the sample mean of the 81 students who are selected? Does that mean it's left skewed because that's what the answer already gave us?
I think it's normal because the sample size is so big. So, do you see my screen?
Yes.
So, the shape will look similar to the population distribution it is drawn from unless
Would be normal then.
n is greater than or equal to 30. Yeah.
Okay, so it would be normal.
Mm-hmm.
Okay, what is the mean of the distribution of the sample means for all possible samples of Okay.
What is the mean distribution of the sample means for all possible samples?
I have no idea.
Um, but I mean, in the video too, she says the mean equals the mean equals the mean. And so I think it would be 3.5. So the mean stays the same whether it's the population or the sample size. Does that make sense?
Mm-hmm.
And considering we don't have data anyway, I'm just gonna go with 3.5.
I feel fine about that at this point.
Okay, let's do it.
Okay, so the next is what is the standard deviation of the distribution of the sample means for all possible samples? So does that mean,
Sorry, just a second.
no, you're fine.
Okay, so all we have to do now is divide the population standard deviation by the
Oh,
square
divided by the square root of n.
the number of samples. Yeah.
So it would just be the 3.5 divided by the square root of 81.
Yeah.
So so is that 3.1 to 3.5 divided by 9?
Oh, yeah.
Is that correct? 0.3888888.
Just a second. Let me redo this.
Huh?
Let me redo it.
No, you're good.
I really don't like this Apple calculator. I can't see what you're doing.
Oh, I know.
I got 0.00777.
What's this? Isn't the square root of 81 9?
Yeah.
So should it be 3.5 divided by 9?
No. So to get the sample standard deviation, we have to take the population standard deviation, which is 0.7,
Okay.
and then
Oh.
divide that by the square root of 81.
Okay. That makes sense. Thank you. Divided by 9. So 0.077777.
Yeah.
Okay.
Or 0.078 is what we put in.
Yeah, it's 4 decimal places, so it's 0.0778. Wait, oh no, it's 0.78, sorry.
3.
You're screwing me up.
Night for me. Still got another assignment too.
Okay, what is the probability that the mean GPA for 81 randomly selected will be less than 3.3?
So now we need to find the z-score and then put it in the applet.
Yep. Okay. So we want to use, so is it 3.3 minus 3.5 divided by 0.7?
I'm not sure at the moment. My brain stopped working.
No, you're fine.
So if we do the problem like we did last time, you're going
Because
to take. Go ahead.
Because is it 3.3 minus 3.5? Because 3.5 is the mean, 3.3 is the value of the data set that we're looking for, and then the standard deviation is 0.7.
No, so how do I explain it? Well, I guess maybe, but how I think of it is 3.3
Mm-hmm.
part of the z-score. Does that make sense? But we're solving for the probability, so maybe you're right.
So are we solving for the z-score, or are we solving for something else?
We're solving for the probability. So it's pretty much finding the z-score. Oh. Yeah, but what if we put in 3.3 as X bar?
Yeah.
Okay, I see where we're going. Okay.
Minus the mean, which the mean of all of them was 3.5 divided by the standard deviation, which we know is 0.7. Is that correct?
It's 0.078 because
yeah.
we need the sample standard deviation, which we have. Let's just go with that.
I love this internet. It was much better the other day. So,
Negative 2.564.
okay, 3.3 minus 3.5 equals divided by, oops. Yeah, 2.564.
Okay.
What is the probability that the mean GPA for 81 students will be greater than 3.3? So won't we take that z-score 2.5? Oh, wait.
So I think we need to take that z-score and put it into the applet,
Yep.
and then just use the left section.
Yeah, for that answer. Is 0.052, 0.0052. So 0.005.
Oh yeah, sorry.
No, you're fine. So wait, is it everything to the left of that or is it everything to the right of it?
I think it's the left, but it doesn't really matter because those two sections are the same.
But it doesn't take in the middle, is that what we're saying?
Oh, right, yeah.
Okay. So 0.005. So is it the same answer for 15 then?
Probably, yeah.
All right.
Yep.
All right, do we want to guess on 4? All
Yeah, just pick one.
right, do we say A, B, or C?
B.
Okay. All right, I feel fine about that.
Shoot. What was 13?
Oh, you're fine. 13. Oh, wait, why did, oh, we haven't answered 15 yet.
Oh,
13 was 0.005. We need to answer 15.
okay.
Okay, so the mean of this is 185. The previous value was lower, but was raised after a boating accident. The standard deviation of passenger weight is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6. Find the probability that the random sample will have a weight that is as extreme or more extreme, either above and below the mean that was observed in this sample. So does that mean we just,
I just think we do another z-score.
but do we use the z-score of the 185 or do we use,
So
so is it 176, 177.6 minus 185, or 185 minus 177.6?
I think it's 177 minus 185.
Okay. So the number 48 is kind of irrelevant.
Well, so that's the sample size.
But
So you can see my screen.
oh, yep, okay. I get it now. Okay, that makes sense. Minus 185, that gives me negative 7.4 divided by, oh, square root of 48. And I want to do 26.7 divided by 4.33333 is 5.00625. So 5.006. I got a negative number. Is that right?
It's going to be negative because you're subtracting 177 by 185.
Mm-hmm.
So yeah, that's fine. We got negative 1.92.
Yeah, sorry, mine did the math wrong. So hold on. Okay, so then I want to do 6.7 divided by 6.1282. Yeah, I got the same answer.
Okay.
So then we're going to plug that in, right? So the chance of there being an extreme above or below is going to be 0.0549. Is that what you got?
.0549.
Mm-hmm.
Okay.
So entered in would be 0.055. All right.
See how we're doing. Oh wait. I have an unanswered question.
No, you're fine.
What's that?
We got 16 out of 17.
What?
No joke. The only one we missed is 14.
High five, girl.
Woohoo! I seriously thought we were going to fail that. Okay. I still don't understand how we did half of what we did, but I feel fine.
So the sample mean is just X. It's X bar. Okay.
That is so irritating, but that's great. At least now we know, right?
Yeah.
Okay.
Hopefully,
All right.
hopefully Greg skips to the end of the video.
Oh, poor Greg. Let me just tell him, if you watch the whole thing, you will get all of them right, but one.
Yeah. Just skip through parts of answers.
Yeah, sorry.
Last time it took us like 5 minutes.
I know. I watched the video because I was like, I think I understand this, but I was like, I want to verify that I'm doing this right.
Right.
So, yeah. And it was so quick. I was like, this is going to be such a quick week. Lies.
Yeah.
Okay.
It's a trickster.
All right. Well, I will see you Monday.
Awesome. Have a good weekend. Have fun in Hawaii.
Thanks. Bye. I will. Thanks. Bye.